Welcome to Study Loop.
So in a reaction of or a mixture of sodium hydroxide and magnesium chloride, the possible precipitate that can be formed is magnesium hydroxide. So if the precipitate will form or not, that will depend on the relation of the reaction quotient value for magnesium hydroxide to its Ksp value. So if the reaction quotient value is greater than the Ksp value for magnesium hydroxide, then this will or this magnesium hydroxide will be formed as a precipitate. So to find the Q value, we have to know the concentration of magnesium ion and OH ion in the mixture. So the initial concentration here for sodium or the hydroxide ion, to know that we are given the pOH value for the sodium hydroxide as 2.58. That means um, the OH minus concentration will be the negative log or the 10 to the power minus 2.5, as the pOH means the negative log of hydroxide ion concentration. And so this will be, and if we just solve it, we'll find the value as 2.63 times 10 to the power minus 3 molar. So this is the concentration or initial concentration for hydroxide ion. And then we are given the magnesium chloride solution concentration is 0.018. And since from one magnesium chloride we will have one magnesium ion, that means the concentration of the magnesium chloride is the initial concentration of magnesium ion also. So the concentration of Mg2 plus will be 0.018 molar. Now these are both the initial concentration of hydroxide ion and Mg2 plus ion, and since we're mixing two different volumes of the solutions, we have to find out their final concentrations. So we are adding so we have to find this from the formula of M1V1 is equal to M2V2. So let's first do it for the hydroxide ion. So if M1 is hydroxide ion initial concentration, V1 is its initial volume, and M2 is the final concentration, and V2 is the total volume of the solution. That means we have to solve it for M2, or M2 for OH minus, that will be M1 V1 over V2, and here M1 is the initial concentration of OH minus, which is 2.63 times 10 to the power minus 3, and the initial volume for OH minus is 75 ml, as we are adding 75 ml of sodium hydroxide, and the V2 here is the total solution volume now, which is 75 plus 125, that means 200 ml. And if we solve this, we will find the M2 value as 9.86 times 10 to the power minus 4 molar OH minus. So this is the final concentration of hydroxide ion, and then in the same way we can solve the final concentration of magnesium ion, which will be the initial concentration of magnesium ion as 0.018, and then we have the initial volume as 125 molar, and the V2 is the total volume 200 ml. Then we will have the final Mg2 plus concentration as 1.125 times 10 to the power minus 3 molar. So this is the final concentration for Mg2 plus. Now we know the both the hydroxide ions final concentration and magnesium ions final concentration. Now the reaction quotient formula for a compound of AMXM is AMXN. For that we'll have AN minus or N plus M, and then we have X M minus all to the power N. So here our formula for magnesium hydroxide is MgOH2. So if we just use or to compare this formula to this, we will have our reaction quotient value for magnesium hydroxide as Mg2 plus times OH minus, and there will be a square for these two. And if we just put the final concentrations values of magnesium and hydroxide ion in this formula, we will have a reaction quotient value of 1.1 times 10 to the power minus 19. And now if we find the Ksp value for magnesium hydroxide from a table, we'll see that the value is 2.06 times 10 to the power minus 13. So apparently from here the Q value for magnesium hydroxide is greater than the Ksp value, and as we have already said that if the Q value is greater than the Ksp value, that means the compound will form a precipitate. That means in this reaction or in mixture, MgOH2 or magnesium hydroxide will be precipitated.